Have you ever paused to consider the world around you? Have you ever wondered why the ocean is salty, a vast expanse of saline water, but lakes often cradled in the landscape are fresh? It's a question that touches upon the very nature of our planet. We see vast, blue oceans stretching beyond the horizon, seemingly endless in their reach, and quiet lakes nestled among hills, serene and still. These bodies of water paint a picture of contrast. Both hold water, the essence of life, the lifeblood of our planet, yet one is salty, a concentrated solution of minerals, and the other fresh, pure, and inviting. Oceans cover over 70% of Earth, dominating the surface of our world, forming a single, ancient, interconnected system, a global network of currents and tides. Lakes are smaller, scattered, and isolated, each a unique ecosystem unto itself. This difference in scale and connection is key to understanding their distinct properties. The story of salt is about what flows in, and crucially what flows out, or rather what flow out. Stand by the sea. The air is briny, thick with the scent of the ocean, the water stings your eyes, a sharp reminder of its mineral content, and salt crusts your skin, leaving a visible trace of your encounter with the sea. By a lake, the water is cool, clear, and drinkable, a refreshing contrast to the ocean's embrace. This contrast reveals a profound planetary process, a story written in water and time. The ocean's saltiness is no accident. It's not a random occurrence. It's the result of a slow, ongoing cycle, a continuous exchange between the land and the sea. To understand it fully, we must start on land, the origin of the ocean's salty secret, with the fall of rain, the beginning of a long and transformative journey. Rainwater is nearly pure, distilled by the atmosphere, but as it touches Earth, as it makes contact with the ground, it begins to change, its composition subtly altered. It picks up minerals and salts, dissolving them from the rocks and soil as it journeys toward lakes or the sea, carrying its mineral cargo. Here begins the story of the ocean's saltiness, a tale of erosion, transportation, and accumulation. Water, the universal solvent; rock, the source of the ocean's seasoning; and time, the patient architect of this planetary phenomenon. Every raindrop, seemingly insignificant on its own, is a tiny force of nature. Each one plays a vital role in a continuous cycle. As it journeys across the land, it acts as a solvent, dissolving minerals as it flows. This process is fundamental to the Earth's geochemical balance. Rainwater is naturally slightly acidic, a characteristic that allows it to break down rocks over time, slowly but surely reshaping the landscape. This process allows the water to pick up ions like sodium and chloride, the very components that make up common salt, enriching the water with dissolved solids. Rivers and streams, large and small, act as conveyor belts, tirelessly working to transport these dissolved materials. They are the arteries of the Earth, carrying these dissolved salts from the land and delivering them to larger bodies of water. Both lakes and oceans serve as the ultimate destinations, receiving this constant influx of mineral-rich flow from the world's rivers. While we often refer to river water as fresh, it isn't truly devoid of salt. It simply contains a very small concentration of salt compared to the ocean. If you were to evaporate a gallon of river water, you'd be left with only a tiny pinch of minerals, a testament to its relatively low salinity. But when you consider the scale of all the rivers on Earth, globally, they collectively deliver billions of tons of dissolved salts to the sea each and every year. And deep beneath the ocean's surface, hydrothermal vents, spewing forth superheated water, add even more minerals to the mix. These hidden underwater sources contribute significantly, working in tandem with rivers, to help make the ocean the salty expanse that it is. So why do lakes stay fresh if they receive salty water? Most lakes have both an inlet and an outlet. Water flows in, lingers, then flows out, taking its dissolved salts with it. This constant flushing prevents salt from building up. Evaporation leaves some salt behind, but the outflow removes most of it. The balance between inflow and outflow keeps lakes fresh. Lakes are waypoints, not destinations, for water and salt. Their water is always being replaced. This dynamic flow sets lakes apart from oceans. Lakes are temporary pauses in the water's journey. The real accumulation happens elsewhere. The ocean is different. It's the end of the line. Rivers pour in water and salts, but there's no outlet. Water leaves only by evaporation, which removes pure water and leaves salts behind. Over billions of years, this one-way process has concentrated salt in the ocean. Imagine a pot simmering. Add salt, boil away water, and it gets saltier. The ocean is a vast, ancient basin, slowly seasoned by rivers and vents. Today, the amount of salt entering and leaving the ocean is balanced. The ocean's salinity is stable, but it remains a salty chemical soup. Evaporation is the key that locked the salt in place. Some, in fact, are saltier, far saltier than the sea. These unique bodies of water present a fascinating study in natural chemistry. These are endorheic or terminal lakes, geological formations with a distinct characteristic. They are defined by having no outlet to other bodies of water. Rivers flow in, carrying their mineral cargo, but water leaves only by evaporation, a process that leaves the dissolved minerals behind. This continuous cycle concentrates the salt and other minerals over time. The Great Salt Lake in Utah, a vast expanse of shimmering water, is a prime example of this phenomenon, a testament to the power of evaporation and mineral accumulation. Once a freshwater lake, it is now distinctly salty, as rivers relentlessly bring in minerals from the surrounding landscape. The Dead Sea, an even more extreme example, is even saltier, sitting in a stark desert valley where the sun beats down relentlessly, losing water rapidly to evaporation under the intense desert heat. Its salt concentration is so incredibly high that almost nothing, save for a few specialized microorganisms, can live in it. These lakes, though unique in their extreme salinity, are small-scale versions of the ocean's much grander salty story. Most lakes manage to stay fresh and inviting, because they're constantly flushed out by rivers and streams. The ocean, however, is salty, profoundly so, because it's essentially a closed system on a planetary scale, accumulating salt and minerals for eons across geological timescales. It's a simple yet elegant process, a fundamental aspect of our planet, nature's patient hand, slowly and steadily shaping our beautiful blue planet. Thank you for watching. Please like this video, and what are your thoughts? Leave it at the comment section, share this video, and do come back for more interesting and educational videos.